Everyone, in this video we are going to start our third chapter of class 7, that is rational numbers. So what are the rational numbers are? See, all the numbers whom we can write in the form of fraction like p upon q are known as rational numbers. All the numbers whom we can write in the form of p upon q, or we can say in the form of fractions, are called rational numbers. And there is condition where q is not equal to 0. This is the condition which should be followed, then only it will be a rational number, otherwise it will be not a rational number. So what I said, rational numbers are all the numbers whom we can write in the form of p upon q, or we can say fraction where denominator is not equal to 0. P is numerator and q is denominator. See, now example of rational numbers can be like fraction 1 by 2 you can write, 1 by 4 you can write. Now if I will ask 5 will be a rational number, now what will be your answer? Some of you can say no, some of you can say yes, but it will be a rational number. Why? Because if there is nothing in denominator, we can write here 1. So 5 will be a rational number. Or if I will ask 15 will be a rational number, definitely it will be a rational number. Means 5 is our integer also, and natural numbers also, and whole number also. 15 is again our natural numbers, whole number also 15, or like this. If I will ask 0 is a rational number or not, so what will be your answer? You can see what is in the denominator of 0, nothing is there, so we can write it as 1. So numerator is 0 and denominator is 1. So what was our condition of rational numbers? That p upon q, where q should not be equal to 0. Here you can see what is the value of q. If you will write in the form of p by q, q's value is 1. So q should not be 0. No? Here q is 0. No. So 0 is also a rational number. 0 is also a rational number. This you will remember. Why 0 is rational number? Because in the denominator of 0 we can write 1. So 0 is again a rational number. Or in the same way others we can write. See, in this way one conclusion we can derive from all above these conclusions, that if there is a natural number, set of natural number will denote with capital N. It will be from 1, 2, 3 and so on up to infinity. Set of whole number, it will be from 0, 1, 2, 3 and so on up to infinity. Set of integers, it will be from minus infinity up to 0 and up to plus infinity. So you can see all the natural numbers will be rational numbers. Why? Because we can write in the denominator 1. So all the natural numbers are rational numbers. Again you can see in case of whole number, 0 upon 1 we can write. So 0 is whole number, 1 again, all these are the same. So all whole numbers will be again rational numbers. All the integers also will be whole numbers. See, you can write an integer minus 2. So what will be in denominator? Nothing is there. So 1 we can write. So it is again a fraction p by q, where q is not equal to 0. See, q's value is 1. So it will be again our rational number. In this way we can say rational numbers are all the natural numbers are rational, all the whole numbers are rational numbers, and all the integers are our rational numbers. If all the integers are our rational number, so we can say the rational numbers can be positive also, or rational number can be negative also. Like positive rational number, which one will be? 2 upon 5, whatever the numbers having positive sign, and negative rational numbers minus 2 upon 5, it will be the negative of this one. Like this we can write. I hope it is clear that what are the rational numbers. Or in symbolically we can write, see, all the natural numbers are, all the whole numbers are natural numbers. Means in set form, no, we can write like this: all the whole numbers are integers will come in under in integers, natural number and whole numbers will come. You can see from here, in these always come under the rational number. This is the same thing I am representing here with the Venn diagram only. That same thing I am telling here. Now come to the absolute value of an rational number. See what is the absolute value. Here I am writing this one, absolute value of a rational number. See, if it is written minus 2 upon 5, in chapter first also we have done, whenever we are finding the absolute value, what we will put here, we will write it mod minus 2 upon 5. So what will be the value after coming out? It will be 2 upon 5. This is the absolute value. Same way, if plus is again, then when it will come 2 upon 5, it is written mod 2 upon 5. What will be the value coming outside? It will be again 2 upon 5 only. Now come to the standard form, that is third one. Standard form of a rational number. See how we can write here. Just see. Standard form of a rational number. See, if a number is written like 10 upon 100. Now you know that this is a rational number or not. You know that in the form of P by Q it is. So it will be a rational number. We can say it is a rational number. Rational number. So is it in the simplest form? As we know that in fractions we have done, in the simpler form what we will do, that no further, other than 1, no further common factor should be there. So in this we can divide it by 2, 2 5 is 10, and this also 2 5 is 10, and 0 it will be. Again we can divide 5 1 is 5 and 5 1 is 5, means 1 upon 10, 10 upon 100 is the same as 1 upon 10 is. See, this is the simplest form of this fraction, and this is also called the standard form of the fraction, standard form of rational number. That will be the simplest form. Now come to the topic that how rational numbers on number line, how to represent these rational numbers on number line. See, up to now we know that how to represent the integers. Suppose this is a number line, here from 0, here will be plus 1, plus 2, plus 3, plus 4, like this it will be, and here will be minus 1, minus 2, minus 3, minus 4, like this it will be. Now you can see these are the negative integers, these are the positive integers, means left hand side value will be negative from 0 and right hand side from 0 will be positive. In the same way, if like this we were representing, the minus 2 will be here or plus 2 will be here. In the same way, if I will ask where we will represent 1 by 2, minus 1 by 2, then what we will do, see here, the easiest way for doing this is you have to represent minus 1 by 2 on number line. See, simply you draw a number line, here you put 0. Now what you will do, in denominator it should be 2, so you will write 0 upon 2. Here you can write 1 upon 2, whatever the numbers were, same, upon 2, 2 upon 2 you will write. Here you can write minus 1 upon 2, here you can write minus 2 upon 2, same. Now you can see 2 upon 2 will be equal to 1, so we can write it as 1. Then minus 2 upon 2 will be again minus 1, so we can write it at 1. So what we want to represent here, minus 1 by 2. Where will be minus 1 by 2? See, 0 by 2 will be 0 only, so minus 1 by 2 will be here. So we can represent here, this is the point A, which is equal to minus 1 by 2. And same way you can do others question also. One thing that you will remember, if it is written minus 1 by 2, whatever the denominator is, that much part you will do, that much partition of that line you will do, or that much subdivision of that line you will do. See, here was 2, so from 0 to 1 how many divisions I have done? 2. If it is will be written like this, see, 0 to 1, from here to here, 0 to 1, how many divisions are there? 1 2. Here also 1 2. So like this you will do. If a fraction will be like this, or we can say rational number, rational numbers are the fraction. See, if a fraction will be suppose we can take 2 upon 4, and you have to represent 7 upon 4. Then how you will represent? See, how many subdivisions you will do? 4 subdivisions you will do. You know na? From here 0 we can do. Here will be 1, 2, 3, 4, and here you can write 1. So what it will be? It will be equal to 0 upon 4, or here you can do same way as we have done. 0 upon 2, 1 upon 1, sorry, 0 upon 4, 1 upon 4, 2 upon 4, 3 upon 4, like this you can write. 4 upon 4, it will be equal to 1. 5 upon 4, and same way 6 upon 4 and 7 upon 4, like this you can write. Now what will be the value? See, 0 upon 4 means 0 only, 4 upon 4 means 1, and 7 upon 4. See, what value we want to represent? 2 upon 4. Where it will be? It will be here. We can represent it with letter A, capital A. 7 upon 4 will be somewhere here. We can represent with capital B. Here we can write 2 by 4, and B is equal to 7 by 4. Like this we can represent. Means that much subdivisions will be there. See, from 0 to 1, how many subdivisions are there? This I want to say, that 0 to 1, how many subdivisions are? 1, 2, 3, 4. Means whatever will be the denominator, that much subdivision will be there between 0 to 1, or 1 to that next number 2. 1, 2, 3, 4 means next number will be 2 here. Like this we can represent the rational numbers on number line. Now come to the equivalent rational number. See, what does the equivalent means? Equivalent means the rational numbers having equal value. Now some examples I will take from here. Now you have to find out. Suppose a number is written like this: minus 6 upon 16 and minus 9 upon 24. See, both these are equivalent or not? See, first you will write both the rational number, this one also and this one also, in the simplest forms. You can check. We can divide it with 2. So it will become, here I am writing, it will become minus 6 to 2, 3 is 6, minus 3 it will become, and 8 2 is 16. This one, if I will divide it with not divisible by 2, so simplest form, both are divisible by 3. So we will write 3 3 is 9 and 3 8 is 24. So both are equal. This is the simplest form, and this is again simplest form. So in simplest form both are equal. So both the fractions, means minus 6 upon 16 and minus 9 upon 24 are equal. How you will find out? First you will write all the fractions in the simplest form, and then you will compare them. Is both are equal or not? If both will be equal, then you will write they are equivalent. If both will be not equal, then they will be not equivalent. Now come to comparing rational numbers. See how we will compare that which one rational number is greater or which one rational number is smaller. A easiest example I am taking here. Just see, 1 by 2. All you know, what does it mean? Half. And here I am taking 1 by 4. What does it means? 1 by 4th quarter, we can say. Now you can see from here which fraction is greater. Here you know that half is greater than quarter, but how we will find out if a fraction is, these we know, that's why we can say by seeing. But if we don't know somewhere fraction like this also, 2 upon 7 or 7 upon 2, which one will be greater? That time you will feel difficulty. So what is the way that we will find out? There are two ways, first one and second one. First way, first method of doing this is, see, first compare the denominator. Here is 2, here is 4. Make denominator equal. How you will do? 2 and 4. LCM of 2 and 4 you will take. So what will be the LCM? LCM will be 4. 2 1 is 2, 2 2 is 4. Like this you can do. 2 2 is 4 will be the LCM. Now make denominator equal. First fraction is 1 by 2. Second is 1 by 4. Make denominator equal. What we will multiply? 2. Here or here what we will multiply? Denominator should be 4 na? So 1 we will multiply, it will become 2 by 4, and this will become 1 by 4. Now what you will do? This is your result. Means this is the first method. Method first, this one, or this is method second, this one. See, in first method what you will do now? Now both are the like fractions. See, both having same denominator. So if both having same denominator, then that fraction or that rational number will be greater whose numerator is greater. This one means if both are the like fraction, this you will remember. In case of like fraction, whose numerator will be greater, that fraction will be greater. That you will remember. Here you can see a second way what it is. See, 1 by 2 it was, and second one 1 by 4. You know that cross multiply, this numerator we will multiply with this denominator 4, and this denominator we will multiply with this one. So what will be our result? Here we will write 4 into 1 into 4 we will write is equal to 2 into 1 into 2 we will write 1 4 ja 4 and 1 2 ja 2. Sorry, no equal to sign we will write, simply we will write and. Here you can see which part is greater, that left hand part is greater, so that fraction, which part will be greater, that fractions will be greater. So you can write here 1 by 2 is greater than 1 by 4. I hope it is clear. In first method what we have done, first we made that denominator same or by taking LCM. In second method what we have done, we multiplied it, we have done cross multiply here, and after cross multiplying, which side, left hand side or right hand side, which side was greater, that fractions will be greater. Here left hand side was greater, so left hand side fraction, that 1 by 2 was greater. Like this you will solve your exercises.